Let n be a natural number. We say that b is an nth root of a if b to the power n equals a. When n is 2, b is called the square root of a. And when n is 3, b is called the cube root of a. It is well known that if a is a real number that is positive, then a has 2 square roots. If you look at the number 9, it has 2 square roots, 3 and minus 3. We are now going to look at how to find n roots of a complex number. And let's first look at the following example. Let's take two complex numbers, z equals 2 times 6 pi over 6, and w equals 2 times 6 5 pi over 6. And if you plot them on the complex plane, z will be around here, and w will be around there. So the angle here is pi over 6, and this angle here is 5 pi over 6. So you can see that these are different complex numbers. But now let's take a look at what happens when you cube them. So we can use the maths formula here. Z and w are given in polar form. So to compute the third power, we take the modulus to the third power and then multiply the argument by 3. So 3 times pi over 6 go inside here. And that's just 8 6 pi over 2. Now w cubed, we have 2 cubed as modulus. And the argument would be 3 times 5 pi over 6. And that's 8 6 5 pi over 2. But 5 pi over 2 is bigger than 2 pi. In fact, is 2 pi plus pi over 2. And so this is going to be same as 8 6 pi over 2. Now, look at these two things. They're the same. So the cubes of z and w are equal. So these are two distinct cube roots of the number 8 6 pi over 2. In fact, there's one more cube root of 8 6 pi over 2, and it's given by 2 6 3 pi over 2. And you can check that the cube of this is equal to this. So in general, if you have a natural number n and some real number r that is positive, then by the maths formula, the nth power of each of the following is equal to r 6 theta. So the list is this. Or more compact way to write this is this. And these n numbers are all the nth roots of r 6 theta. So if you are given a complex number in polar form like this, then you can write down the nth roots by just writing down this list of complex numbers. And now let's look at an example. Suppose that we want to find all the cube roots of minus 8. First, you need to convert minus 8 to polar form. It is 8 6 pi. So the cube roots will be this list here, where n is equal to 3. So I would have 2 times 6 pi over 3, and 2 times 6, 2 pi over 3 plus pi over 3, and 2 6, 4 pi over 3 plus pi over 3, and that is the same as 2 6 pi over 3, 2 6 pi, and 2 6 5 pi over 3. And if you want to, you can convert these to rectangular form, and this one will be 1 plus square root of 3i. This will simply be minus 2, and the last one will be 1 minus square root of 3i. Now notice that we have here minus 2, and we know that minus 2 cubed is minus 8. So this is precisely the cube root of minus 8 that we would have written down before we had learned about complex numbers.